Hey fellow Mystifiers, it's MysticDragonEX here, and this video is dedicated to me getting 100 subscribers on my channel. Like, this is such a big thing, 100 subscribers for like a YouTuber like me who just like uploads average size videos and normal science experiments and games. It's such a big thing for me, and we will climb further after this. So for this 100 subscribers special video, we are gonna open and review this National Geographic STEM Vanishing test tube experiment. This is actually a cool experiment. I already tried it, but let's review it right now in this video. So let me open this. Typical unboxing. Whoa, we got oil sticking out here. Let me see it. Okay. There's some manuals out here, and we have got this. Let me put this aside, like right here. We've got this. Here it is, a beaker and a funnel, good test tube. It's Pyrex glass, I guess. It might be written here somewhere. Oopsie, it's not written, but I guess it's Pyrex glass. But this is actually a good thing, glass one in good quality. Let's see what all the oil here I have here. We have a oil, this thing, okay, vegetable oil sample. I guess this is our refractive material. So this, let me see this guide here. Here just normal science behind optics. Yeah, we will be checking this out also in between our video maybe. And here we have got a manual thing. Okay, so we need water here, and we need to fill this thing 2/3 with water, 1/3 with water. We will see how it goes. So yeah, let me first come by filling this with water. So whoop. So we have got ourselves 1/3 of the beaker filled with water. So let me set this thing right here. Let's see. If we want to change the angle of video, we will see. We have got this thing and test tube, and I guess we have to fill this with vegetable oil. So we are gonna just do it right now. And yeah, let me open this. And I guess we stick the funnel over here and then pour the vegetable oil so that we get ourselves this much of vegetable oil. So get at least a good amount of height on this test tube. So yeah, let me come out this like, whoop. Oh yeah, we back. So I have just filled it, the oil about this height, almost at the brim of it. So yeah, now we're gonna see what happens. Let me remove the camera angles from here. Yeah, let me get this right here. So this is our glass beaker with water, and here we have our this test tube filled with water. So now all we have to do is take our oil sample just here and pour almost the same amount of oil as we have the water here. So it's 20, so almost as 40. You see how much we got here? It's actually a little bit more, but no worries, oil would eventually spread itself out. Also, you can see a double layered oil sample here. So it means water and oil, two immiscible liquids. That's why oil is actually less denser than water, so it floats above water. Water is little more denser than oil, so it stays in bottom. So we see they have formed two separate layers. At top is oil and below is water. And we have test tube filled with oil. Let's see what happens when we pour it up. We got it inside. Oh my gosh! What? Look at what we have here. There's no test tube. We can see this thing. Look at this. It's poking out from here, and literally this is here, and we cannot see the test tube. That's so weird. Like literally, look at this. There's no test tube anywhere else. And see my finger behind. Now, why the test tube is not there? Let me explain. So you see here that the refractive index of oil and this beaker, they have made it so that the refractive index of this beaker and the oil are exactly the same, almost exactly the same. So, and this glass also, this test tube also has the exact same refractive index as this beaker has. Now, what is refractive index? Well, it's the when light comes through this test tube or this beaker or any other liquid substance, it's just refracted by a certain angle or amount. Now that's called refractive index. So you can see, like, you see test tube is this much only thick. When you pour into it, it gets enlarged. Now the measure of it getting enlarged is the refractive index. So here we have the test tube and the oil, test tube and the beaker's refractive index are almost exactly the same. So that's why it gets overlapped, the light coming here, it gets overlapped by the beaker, oil and the test tube. So you cannot see any sign of even this thing, the glass and this beaker, or the test tube and the beaker. So you can see it not being here, and as the test tube is also filled with oil and the beaker is also filled with oil, so they would all obviously overlap, and you cannot see any sign of test tube being obstructing the view of us. So you can see literally it's diverged, and you can see there's no test tube. Even if I turn it, you can see there's nothing in it. Now what if you mix it? Let's say, what if you mix it? Even if you mix it, you can see little thing moving. That's just the oil getting disturbed, oil stagnancy. But you can see here. Look at this. Now you can see there's a little bit reflection coming on here. But as we just leave it undisturbed, there's no test tube. Oil. That's so weird. It's just like an optical illusion to your eyes, but it's just light playing fixed on your eyes and your brain. Brain interprets it as one image, but where light is actually getting refracted from different media, but our brain sees that one image because the refractive index of those media are actually the same. So it's just so weird. Even if we take this out, and he's just drenched into it, and as you can see, I even mixed it up, but it didn't mix. That's why they are called immiscible liquids. That is the liquids that do not mix even after essentially mixing. So let's try different experiments now. So we have got the test tube. So now let's dip it into the oil, but it doesn't come below the water like this here. You can see there's nothing actually in. If we just leave it undisturbed, whatever you are seeing, or I guess please focus. Oh my gosh, it's not focusing. Oh no. Focus, I got, okay, here we have it. Just remove that thing, okay, yeah. You can see it's just a little bit of difference. That's just the light bending from around the edges of the test tube, but overall you cannot see anything, right? It's just plain clear thing. And also there are air bubbles around the test tube. That's just because I dipped it so air didn't get time to escape, so it formed bubbles. Let me take this out and then let me quickly just dip it, and you can see what's the difference in it. Here it focus. You can see for 1 second there is a bubble, air bubble that I do. That's the surface tension of the oil that causes a bubble also to form just above the test tube lid. You can see that's so weird. It's just like for only 1 millisecond of like time you see, and then the next second is gone. Like it's so weird. And then you see all the remaining air bubbles on the test tube. It's so weird. Then let's you can see there's little thing. There's little thing there. Water layer and oil layer. And then we put it down, and then you can see this oil thing there. And then they disappear. That's just because they are not they're immiscible liquids, and then when we dip the test tube, so it just stays, oil layer just stays on the test tube, and then after some time when you leave it undisturbed, it just goes. So main objective is, you cannot see the two layers of oil and water, but you cannot see this part of the experiment, the test tube. Where is the test tube? That's just the light playing tricks on your eyes. So yeah, this was my experiment, or actually this was a science kit experiment. So yeah, and now as I promised, now let's see what the manual has to say for us. So this is the manual, and let's see, vanishing test tube instruction manual, normal typical things, first aid, safety rules, yeah, whatever. Make your test tube vanish, yeah, that's exactly what we did. 3/4 full of vegetable oil, same thing, but we first added water to just demonstrate in front of you how to pour oil. Actually, I didn't pour it on the video, I just poured behind the scenes. So yeah, so fill the beaker about 3/4 full of vegetable oil, that we did. Submerge the empty test tube. Now this is experiment 1. I didn't do experiment 1, I just did the experiment 3, when we put both the layer of oil and the water. Well, I tried out experiment 1 and 2 before. It's not that great, because there's oil and then you leave the empty test tube most of way into the beaker. That won't do anything, because then you can see the air fill in the test tube. It's not that great. Then they pour oil after in the test tube, so then you can see magically getting disappear. It's not a big thing for now. We demonstrate the full experiment where we put water and oil and then we got it. So yeah, this is experiment 2. If you want it, you can read it. You can pause and read. So yeah, experiment 1 and 2. Let's turn. Here we have, yeah, this is actually what we did. 1/3 full. Yep, exactly. Equal amount we did. 2 distinct layers. We got 2 distinct layers. Using the funnel, carefully fill the test tube. Yeah, I already did that. I filled it until it was nearly full. That's what I did. And then the same thing, holding on top of the test tube, slowly lower it into the beaker. Portion of the tube is underwater is visible. You can see the portion is visible here, exactly like this. Let me put it in the front. And the part in the oil is not visible. Simple. Oil vanishes. Exactly. Now some what if questions. Now as I told you about the refractive index, we will read the learning guide also, but these are the questions that you can try, and you can give me the answer in the comment section. Let me read these questions for you. First question is, what if you use a different kind of oil? Do all oils work the same way? Well, that's a question for you to answer. I'm just giving the hint. Try first knowing the refractive index of that oil and the beaker and the test tube that you're testing, and then try to ponder about the situation of what would happen if you use a different kind of oil. Would it still show this disappearing phenomenon, or would it show something different, like distorted phenomenon, where the test tube is like here and there distorted? Yeah, these are all the questions that you have to answer. Let me read the next question. So, what if you use a container made of regular glass instead of the special glass of your science? Well, some of the questions I have made, this question is so obvious that if we took a regular glass, then the refractive index of the test tube would be different from the glass that we took. So the test tube would be visible, oil won't be visible, the test tube boundary would be visible in the beaker. So this is just an easy answer. Okay, now there's a third question. What if you drop other glass objects such as beads or marbles into the vegetable oil? Would those disappear as well? Well, that's an interesting question for you to ponder about. Well, if you answer all these questions in the comment section, I would try to reply to them or include them in my next video on highlighting those people who gave the answer. So that's your task. Now, what do you predict will happen if you put other materials such as pencil or straw into the oil? Try it and observe what happens. What does it tell you about the beaker and the oil? That's all you have to do, and then the rest is just translations of this from say of Inkill. Yeah, all these things. So yeah, this is all about the instruction manual. Let's see the learning guide. And the other is translation, so we won't read that as well. Let's read the learning guide and see what it has to offer to us. Science behind optics. You can exactly pause this and read this. It's just telling how refractive index works, and actually this is the refractive index diagram. The light is being refracted, and seeing here, this is the actual position of the object, and light coming from it gets refracted by some angle. I told you the angle determines the refractive index mostly. Yeah, we see the light refracts, hits our eyes, and we perceive it that the object is actually here. This is why actually when you see a pond filled with water, the pond's height is actually not that as much as you compare it without water. Its height would be a little bit lower than you see, but actually it's different. So here we have different things about light, how it behaves in different media, and they're explaining. Obviously you can pause and see what is up they have to offer. I'm gonna tell everything and just show. Here same thing. Speed at which, yeah, exactly this. Speed at which light waves bend is called the refractive index. This is the refractive index definition. I explained you in the easy way. Well, then the rest is all the same thing. And here it is also telling the beaker and the test tube. As I told, they have same refractive index. Yeah, same exact thing. I'm not gonna show everything here. Perception thing is there. You can read everything when you pause, just being a little bit quick. And these are actually optical illusions. Okay, here we have two faces here, like this is a cut face or this kind of side face. They're all optical illusions where we perceive things different ways. Then bonus activities here you can do. I'm not gonna read it. You can just pause and then you can see. Let me all get this thing to you. It's just all easy things. Illuminate the laser, aerosol spray. This aerosol spray you can get in the market. That's just easy things. Let me get a new one. Now here it is more optical illusions. You can take this thing. You can take the screenshot and print the screenshot and then paste them in your notebooks or whatever. Just fool people. It's just easy things. Here, normal things. More optical illusions. These are all optical illusions. Well, you can see here if you want to. Let's take a spin to a foreign place. These open highways are calling our name, and now it's time for us to escape. Well, rest are all optical illusions. So, well, basic thing is you need to know how refractive index works and how different things behave when they have the same refractive index, and different media when we put things of the same refractive index in that media, things disappear and maybe different things could happen like distortion. So you can take 3 layers of vegetable oil, soap and water. Just different things like how things would behave. You can take soapy water and then try with vegetable oil. Maybe that will cause a big difference or not. It's just up to you how you can play with science and create different things. Yeah. Thanks for watching this video, and if you like, please share this video and like and comment down whatever task I gave you. And if you have any doubts regarding this, I am going to reply to you. Just comment your question in the comment section. I would try to reply to you. I reply to every comment that's been posted, but that's such a big thing for me. Getting 100 subscribers, I never expected that to get them so early. I don't know who watches my videos. It's just so good. Feels so good. So yeah, this was my 100 subscriber special video. If you liked it, do like, share, comment and subscribe to my channel. That we're gonna hit more target at 200, 500, 1000 subscribers special. That would be epic if we reach there this year, maybe 2-3 years. Yeah, thanks for watching and stay tuned for more mystifying copy here.